So I'm going to introduce Jonathan Wolf, who is the founder and director of engineering at iCentropy. Jonathan is an ex-physicist who operates a consultancy specializing in big data and data science projects. He's worked for Bloomberg last year and built their Accumulo file system, was actually presented in 2015 Accumulo Summit as a keynote speech. He's also done a distributed computing project for work with Yahoo and Pig. Jonathan holds a BA in physics from Harvard and an MS in mechanical engineering from Columbia, and has been an avidly programming since the 1980s. Jonathan.
Hi. So, Accumulo Collections is basically an attempt to make Accumulo user-friendly and speed up development of applications, and make Accumulo accessible to people who don't really understand the internals of it, especially iterators. So the things that I see about Accumulo, when you just take it out of the box, it's a byte map. It doesn't really understand the contents of the bytes, so it needs layers to handle serialization, and so it can interpret Java objects, and handle foreign keys. Joins is another thing, so that you can easily join to other tables. And then the main thing is the abstraction of iterators. I think it's really hard for people to get up to speed with writing iterators, and there should be a sort of simple abstract classes you can extend to write iterators on Java objects rather than bytes. So, and the other thing is a useful library of functions, sort of like MySQL, so like sum, count, all that kind of thing. So first you have to be able to read the bytes, and then you want to do operations on them in a distributed fashion. And the thing about Accumulo Collections is that it abstracts the iterators into just Java methods. You can just run these iterators. You can run this a Java method that will, in the background, set up iterators, scan side iterators. So you don't really have to know about iterators. So Accumulo sorted maps, Accumulo Collections, it's based on the concept of sorted map. So it's a full implementation of Java sorted map. So all the functionality that works with Java sorted map, key set, entry set, all that kind of thing, that's all implemented. And it also, you provide a Surda. So the Surda interprets the bytes locally and also on the tablet servers. So an important factor is that the tablet servers actually read deserialized Java objects. You tell the tablet servers how to read the Java objects. And that makes it easier to write iterators, but you hardly even need to write iterators because a lot of things are bundled with it that basically duplicate the functionality of MySQL, but I think also add a lot of extra functionality, which I'll talk about. But basically, it's supposed to be an alternative to MySQL, so companies can just use this right out of the box without understanding the inner workings of Accumulo. Right. So this is the style of Accumulo Collections. So you see, you have a AccumuloSortedMap object that implements the SortedMap interface, and you just call methods on it, and these methods so all the data pulling is lazy. So in the first example where it says derived map, time filter, sample, that doesn't actually pull any data. That's sort of a recipe for how to pull the data. And I'll get back to the sample function later, but basically the derived maps are themselves Accumulo sorted maps. They have the same functionality as the original maps. So you can use everything just is based around the sorted map interface. That's an important point, that the derived map functions sort of run instantly. They're sort of a recipe for how to construct the iterator, and then when you iterate the derived maps, it knows to add the iterators to the scanner, and so it only pulls data when you read from the maps. So it's all lazy. It's almost like a Java sorted map in every way, except that there are a few little differences, and I'll explain the important differences right now. So, of course, when you do when you get an object off the in-memory map, you don't have to put it back to write your changes. It's all in memory. With AccumuloSortedMap, you have to actually put the object back on the map. The second thing is, and I'll get back to this later, the Surda has to serialize the bytes in the correct sort order. So I'll get back to Surdas later, but there's some intricacies with Surdas because Accumulo uses the bytes writable compare method to compare byte arrays on the tablet servers, and there's really no way to set an alternate comparator. So that's an important point, that you have to be a little bit aware of how you're serializing. But the default serializer that I have in there works with Java primitives, strings, byte maps, and and it also serializes Java objects with Java serialization at the moment. But you can write all kinds of custom Surdas. So the main thing is to get it working with Java primitives and strings, I would say, right now. Also, it supports sizes larger than max int. So the size as long method returns a long size. And it can be set read-only. So there are ways to avoid corrupting your map, deleting your map by setting certain flags in the map, and that'll throw an exception if you try to write to it. So that's just a protection. So here's an example of what the code looks like. And you can see that it looks very familiar to Java programmers who've ever worked with the Java SortedMap interface, that you could just give someone an AccumuloSortedMap, and if they're familiar with the Java SortedMap interface, they are able to work with it right off the bat. So the first line, I'll talk about factories more later, but the factory basically configures the map metadata, and so that when you call factory.makeMap, it's all set up for you. So in other words, the Surdas, and also other things like it has the capacity for like timeout and things like that. And I'll get more into that. But the factory handles map creation, so each time you call factory make map, you get the same uniform map. So you put a bunch of longs in the map in this example. You can use a get command. You can use all the normal iteration you'd expect with sorted map interface works. And the submap routine, all these chain derived map calls modify the scanner. So the submap obviously modifies the scanner's range. The size function is implemented with iterators on the tablet servers. So like the SQL guys before me, I wrote a custom iterator to calculate size, for example. But I've custom iterators for a bunch of different things. But another example would be the key stats method, and that is also implemented with iterators. So for example, the key stats method, there's an iterator that performs statistical aggregates. It's based on Apache Math. So statistical summary in Apache Math. And the tablet server iterators can deserialize the Java objects and compute these per tablet aggregates. And then the tablet aggregates are actually aggregated locally. So it's sort of similar to MapReduce. Each tablet server generates its own sum, and then these are aggregated locally. And below that, the iteration example is just an example that you can use the exact same iteration loop that you would use normally. The bottom shows two examples that will throw exceptions because they're both read-only. So an important thing is that when you make a submap or a derived map, which is you take an original AccumuloSortedMap and you call some method on it, it always comes out read-only because you're not modifying the table, you're actually modifying the iterators, so you're modifying what you see from the table. So there's a way to save your modifications in a new map, but you can't write directly to a derived map. They're like layers above the original map. So in addition to sorted map interface, there are a host of other features I'll get into right now. So one is just timestamping, right? You can look at the insert timestamp of an element, and this is uses Accumulo's internal timestamp. You can filter. There's a timestamp filter, so you can easily just filter, and that of course is another sorted map, another Accumulo sorted map. So you call that method, and then you can keep chaining these filters and transformations on it. Another thing would be like setting out a timeout for data. So for example, if you want your data to only last 5 seconds, you can set a time to live in milliseconds. And this uses the age-off iterator. So as I said, this framework abstracts a lot of accumulator functionality into simple Java methods. So you don't need to know what the age-off filter is. You just do set timeout, and that will implement the age-off filter for you. But in addition to that, I also have Regex filters. So this also runs on the tablet servers. So the tablet servers see the Java objects. They run toString, and then you can supply regexes that would filter out keys and values that you prefer. So in this case, it's filtering out a key regex, but you can also do the same thing with the values. So in this example, AC and AB would be allowed, but AX would not be allowed. And again, all these methods, I keep repeating this, all runs on the tablet server, it's all chained, and it's all lazy evaluation. So So another thing is the sampling features, which I think is a particularly useful feature. There's a sampling iterator that you can do a random sample with it. In the first example, so this is something you may be familiar with. This is just sampling half the entries, right? But in the second example, you can define a sampler, and the sampler sort of freezes a set of the map. I think I should go in a little bit on how that works. You supply a sampling seed, which is a bunch of bytes. So you can even supply random bytes. You can supply a string, which will be interpreted as UTF-8. And that brings an ordering of the keys. I mean, it computes a hash. I think it's a SHA-256 of the sampling seed and the key bytes. And so each sampling seed has a new ordering of the keys, basically. So and then the fraction that comes after the sampling seed indicates a range within that hash. So 0 is 0, 0, 0, 0, 0. 1 would be FFFFF for the number of bytes in the hash. And so the hash range uniquely identifies elements. And if you use the same sampler, it'll pick out the same elements each time. The final parameters are the from timestamp and to timestamp, because if things are added to the map, that would add to the sample. So you can freeze the sample by saying, I want to freeze it between entries that were inserted during a particular time. So the sample object is itself serializable, and you can just save a sampler. So the sampler is like a recipe for how to create your derived map that is a sample. So it doesn't actually save the sample itself, it saves the parameters, it saves the sample seed, which is the recipe for how to generate the sample, and then you can recreate that sample later. So I think that's a useful feature also. Okay, so and then more map aggregates that are computed on the tablet servers. So in some functions like size, for example, there's a map-wide checksum feature also that uses the Java hash code, and so you can have integrity checking that way. Key stats is numerical stats of the keys interpreted as Java numbers. So if your key objects don't deserialize as Java numbers, then they won't be included in the key stats or the value stats. And value stats is for the values also. So similar to key stats, but does it with numerical interpretations of the values. And it's kind of similar to MapReduce in that each tablet server computes its own aggregate, and then those aggregates are then aggregated locally. So you can think of it as like the number of mappers or the number of tablet servers, and the number of reducers is just one. It just aggregates it locally. Another feature is the efficient one-to-many mapping. So you can also, so there's a versioning iterator in Accumulo that allows you to save multiple values for a given column. And so in the efficient, in the one-to-many mapping mode, you can set a function called, I think it's called set max values per key. And then that will set the versioning iterator. So in the same way that timeout sets up the age-off iterator, this method sets up the versioning iterator. And then everything else just works as a standard map, except that there are some extra methods to pull out the multiple values per key. So those are the two I have listed below. There's getAll. It's an iterator over all the values for a given key. And there's a multi-entry iterator that will iterate over all the multiple values for all the keys in the map. And the important thing about this is that this allows you to do server-side per row aggregates, like SQL group by. So I'll show you an example of that. So the first line says unlimited values per key. And then you see that it's map put, map put, map put. So if you called map.get1 after you put 4 into the map, it would return 4 because the last number you put in is the top value with the highest timestamp. But the other ones are still in there. The sorted map functions only refer to the top value, but these other functions and these getAll and multi-entry iterator refer to all the elements, all the values rather. And then so I was saying you can do aggregates by row. So there's this thing RoseStats, right? RoseStats again sets up an iterator. Does nothing but set up an iterator. So when you when you call RoseStats.get1, that's when it actually pulls the data and computes the aggregate. So statistical summary is part of the Apache math package, and so what this is really it's a map of each key value, so in this case 1 and 2, and then it maps them to a statistical summary per row of the values associated with that key. So, so in this example, you can get the mean and the max of the first bucket. So the first bucket has 2, 3, 4 in it, right? You can also count the multiple entries when you're doing your size functions. You can pass a Boolean which says count all the entries, and in this case, there are 4 entries. And similarly, there are some functions. You can do value stats with over all the values or just one value, for example. So, in other words, considering just 1, 4 and 2, 22, or 1 and the whole bucket and 2 and 22. So, okay, and then it provides a framework also for writing your own iterators that work on deserialized Java objects. And that's super important because you never have to work with bytes with Accumulo Collections. Everything's in Java objects. So when you can extend these classes, and the methods are like super simple. So here, transform value, you just return a Java object, or allow. That's similar to the filter, but the first one is in a transforming class. The second one's in a filter class. But the difference is from the normal filters that these work on Java objects, so it's really easy to implement your own. And as an example of a custom transformation, I implemented a script transformation in JavaScript. So what happens is the key and the value get bound. This uses Java's script engine, by the way. This is built into Java, so you can run it. It would work with other languages other than JavaScript, but JavaScript's what I've implemented right now. But the key and value bind to the JavaScript variables key, k, and v. So in the first example, you can just do map.js filter, and you can specify, it looks for the value of the Boolean. So Java has a way of the script engine has a way of interpreting Java objects as JavaScript objects. And this works with numbers, strings, as well as Java maps. I don't have an example of that here, but you could have k, and then in brackets, you could fetch an element from a map also in JavaScript. And one thing I'll say about the JavaScript transformations, I think it's really interesting. I think it's sort of like a how-to, but the script engine has no security checking, so I included this in an experimental package rather than in the main package. But I think this is an interesting direction to go in. So you can transform by supplying scripts that are passed to the iterators. The iterators invoke the scripts and the objects, and they know how to represent the objects as JavaScript variables in this case. So. It also has a concept of foreign keys for joins. So a foreign key is just like a symbolic link to another table plus a key, and it's serializable itself. So currently you can just have foreign keys in your map and pull the foreign keys because they're indexed. They're looking at another key in another map. But this operates locally right now if you're using foreign keys. But I heard a talk earlier about doing this on the tablet servers. So in future versions, I believe there's a way with iterators to iterate and join 2 different tables on the iterator. But I think you have to make a connector to Accumulo. And if anyone has any expertise in that, I'd like to hear about it. But this is the way foreign keys work. They're just basically like symbolic links to a map plus a key. And I spoke earlier about the SortedMap factory, so I'll get more into that right now. The factory is itself backed by an AccumuloSortedMap, and it manages your map metadata, but also manages there's like a namespace associated with it. So for each map, you define your own name for it, and then it will assign an Accumulo table to it with a bunch of random characters on it, so that you don't have namespace conflicts. So if you made one map in one namespace called map 1, and you called another one map 1 in another namespace, they would not write on each other. They wouldn't step on each other's toes. And the factory also sets up Surdas and other configuration parameters. So I have an example. So in this case, there's the factory add default property means that so for any map that comes out of this, so there are default properties, and then the map-specific properties overwrite the default properties. So in this case, I'm adding a default property that says max values per key. That's that efficient one-to-many mapping, so that every map will have that pre-configured when you call make map. And then in the second example, I have an example of when you specifically make the map called my map, it will set up that time to live, that timeout feature. So it comes out of the factory pre-configured. So when you're instantiating these maps, you hardly have to do anything except set your factory up and call make map name. And then other people who are, people who are unfamiliar with Accumulo can just use a sorted map that's pre-configured in the right way for them. So they don't have to mess with Surdas, they don't have to mess with anything. The admins can set up the tables, for example. So it makes it really easy. I mean, it's very accessible for people who don't know Accumulo at all to use this stuff. Okay, so more about Surdas. So I mentioned earlier that on the tablet servers, they only use the bytes writable, like a strict byte comparison to sort the keys, right? And you really have to sort, if you want to maintain sort order, if you want to have the sorted map features work, you have to implement a serialization that respects where the byte sort order respects the Java object sort order. That's very important. So I also bundle a Surda that handles that for you, called fixed point Surda. And rather than store like doubles and floating point notation, it stores everything as a fixed point. So it's basically one long for the integer part and one long for the fractional part. It's not the most efficient way in terms of bytes to store this, but it does sort in the correct order, and that's the desired feature. And it works within the whole long range. So I think it's sufficient for most applications, for most ranges of numbers, Okay, and I mentioned earlier you can also save derived maps, right? So there are features to batch put calls to the map. Each put is rather expensive because if you call a put, it's going to flush the mutations to the map immediately. So as you all probably know, if you use their batch writer and you write a bunch of things and then flush, you save a lot in terms of performance, in terms of time. So the put all feature, which is actually part of SortedMap, if you put another map, that will write it in batch. And similarly, the import all method is similar to put all, except it runs over an iterator. So you supply an iterator of key values. And aside from the batching, they don't do anything special. It just batches the entries. There's another way I just added to batch entries that I'll document on the GitHub. You can see that. But you can also, there's a new cache put and cache delete, and then you can do flush cached changes. So you can, rather than passing an entire map, you can do atomic puts and deletes, and then flush your changes. So that's a performance issue, and that speeds up performance considerably. And I also did some benchmarking. So I didn't have a really high-performance Accumulo cluster on hand, but I did make one in Docker that has all the moving parts. And I expect that Accumulo Collections will add very little overhead to normal Accumulo operations, because all it does is serialization and it handles iterators for you also. So in other words, it handles scan-side iterators. It gives you the recipe for how to add the scan-side iterators. So in my benchmarks, every one I've done so far, which is this toy Accumulo cluster, mock Accumulo, mini Accumulo, every test I've run shows that Accumulo Collections adds very little overhead, and I have a little, these are just some rough tests. I mean, this is, as I said, not a very performant cluster, but it just shows that in this particular example, that the orange one is Accumulo Collections, and the blue one is a test method that writes raw data to Accumulo in the way you're familiar with. So you can benchmark, benchmark the writes, the puts versus the normal Accumulo writes. And there really is very little difference in speed. So it really adds very little to Accumulo, but makes it much easier to use and much more productive. So I'll go over some performance tips also. So the batch writes, as I said before, are much, much faster. As you can see from this graph also, you can see the median time for an unbatched write is like, it's I don't know, like 7 times the batch write. So. There are certain strategies you can do to improve performance. So one of the things you can do is to write changes locally to a memory map and then call put all. And as I said, put all always batches. So you can just batch things locally that way. And I said that there are new methods now, so you can atomically put and delete and then call flush, and then it will do that. So the other thing is that individual get commands I found are fairly slow in Accumulo because it sets up a scanner. So I think Accumulo is more suited to iterating over ranges of rows, but the individual get commands can be kind of slow. So if you want to do a lot of get commands, first of all, you can iterate over a submap. That's pretty fast. And the other thing you can do is to cache a local copy of the map. So I should have put the method signature here, but there's a local copy method in all these maps which just writes it to a tree map. So if you wanted to take a submap of your map and then just do a bunch of queries against it locally, you can do that in memory. And that's a useful feature, I think, also. And it's worth pointing out also that the local copy method, which returns a tree map, is, of course, also a sorted map. So the same interface that works with the Accumulo map works with the in-memory map. I think it's important. And that's actually all I had planned. So we have like, 5 minutes for questions, I guess. Yep.
So it seems that the put all method seems to be actually doing the writes in the background. The put all methods will actually do the writes to the Accumulo.
Yeah. Yes.
Okay. I don't know how to pronounce it. Surdas, like.
Yeah, a serializer, deserializer. I think it's very similar to the lexicoder also. I wasn't aware of lexicoder when I was Surdas, but yeah.
So whatever data you put into this collection framework will get serialized and put into Accumulo. So if you were to actually do a query from the Accumulo shell, you would not expect to see that data.
No, if you do, it's all serialized according to the Surda, right? So yeah, if you do a query in Accumulo shell, depending on your Surda, you may or may not be able to read it by your eyes, you know. But of course, it's not going to be in a readable format unless you can read the bytes and make sense of them. Yeah.
SortedMap, you mentioned earlier that. So how does it work with the batch? Sorry, batch reader, because the batch reader is not guaranteeing any order when it reads from Accumulo, right?
It makes a scanner and then makes an iterator over that. But I believe the rows are returned in order. Am I wrong about that?
Maybe I could be wrong. I might have missed.
I've never seen the rows not be in order. Not for batch scanner. Okay. I have to review that. I haven't seen that actually. But if that's the case, then I'll have to make some code changes. But I haven't actually seen that issue. It does not return the rows in. Okay, so maybe I'll have to change the type of scanner then if that's the case. Yeah. Yeah.
Question was, or actually the last question is SortedMap. Does it do like say when you're like putting anything or reading anything, does it actually fire off MapReduce jobs in the background to achieve what you want, or?
No, it doesn't.
Okay. And what about things like getSum methods which were on the map where I'm assuming it's supposed to get you the sum of the values of that particular map. So does it do a MapReduce job?
No, as I said, it doesn't use MapReduce. In the case of sum, it'll compute a sum for each tablet server, and the sums will be aggregated locally. So it's similar to MapReduce, but it's not quite MapReduce. Yeah.
And as far as getSum, for example, is concerned, is that specific to having numerical values as a value for that, or what happens if you have non-numeric values?
Yes. So as I said, the Java objects that are interpreted as numbers.
Okay.
So like the Java number interface, long, short, whatever. If it's a number, it'll feed that into the aggregate. Yeah. Also, this is the GitHub page, and this is my contact information available for hire also. Yeah. Any other questions? Okay.